So the next lesson in this unit, we're going to start looking at two different types of sequences and series. We're going to start with something called an arithmetic sequence. So an arithmetic sequence, I'll kind of write a couple here. So let's say I do -2, 1, 4, 7, etc. Or maybe like 20, 18, 16, 14. So if you look at what the pattern is, right? The sequence in general is a list of numbers that follow a specific mathematical pattern. So if you kind of take a second and look at what's happening, what is the pattern in each sequence? So this one, to get from -2 to 1, I added 3. And I added 3, and I added 3. This one, I subtract 2, subtract 2, subtract 2. So in terms of like the definition of an arithmetic sequence, it's a list of numbers in which you get the next term by either adding or subtracting the same value every time. So I'm just going to write those examples. I should have just done this here. So again, they follow a pattern in which you're adding or subtracting the same amount every time. Or like 20, 18, 16, 14, etc. Okay, that value that you are adding or subtracting is called your common difference, and it's labeled with the variable d. So if we think about what type of functions follow this same type of pattern, so when we're adding or subtracting the same amount, an arithmetic sequence is basically a linear pattern. Okay, so it follows the equation, kind of follows the same characteristics as a linear function. So the formula that we are going to use to write what's called the nth term, so that just means we can use that equation to find any term in our sequence, is a sub n equals a sub 1 plus n minus 1 times d. Okay, now the notation in this unit is what can make things kind of difficult. You really have to make sure you understand what this notation represents. And so a sub 1 is your first term. A sub n is the nth term. So it can be anything. If we want it to be a sub 20, that would be the 20th term in the sequence. Okay, so then this n right here should be whatever that value is. So a sub n is the actual term itself. N is the placement of that term. And then d is our common difference. Okay, so this is kind of similar to point slope form of a linear function, right? Point slope form is y minus y1 equals m times x minus x1. Okay, so that common difference would be similar to our slope, and then our y1 would kind of be like whatever that term is, and then our x value is at the actual term number itself. Okay. All right, so let's just look at some different examples here. So first, just deciding, is this sequence arithmetic or not? Oh, and I realized kind of subconsciously I chose the same values here. So I'm going from 1 to 4 to 7 to 13, or to 10 to 13. So I'm constantly adding 3, So that means this is arithmetic. My common difference is 3. This one, I'm going from 5 to 3 to 1 to -1. So this is also arithmetic. And I'm subtracting 2. So my common difference would be -2. All right, so now we're going to start looking at some different formulas here and like the different information that can be given to us to write our formula. So when the directions say to write a formula for the nth term, that is to write this formula using the specific information from that sequence. Okay, so these are always going to be like my variables in that final equation. So we need to know A sub 1 and D. Again, it's kind of like here, we would use a given point to plug in here. Y and X are always my variables. So when I look at this sequence, we need to first figure out what's happening. What am I doing to get from one term to the next? It looks like I'm adding 3. So my common difference would be 3. And then in this equation, I need to know the first term. So the first term is going to be -12. So that means that my general formula for the nth term would be A sub n equals -12 plus n minus 1 times 3. So I can now use this equation to find any term in this sequence that I want to. So if I wanted to know what the 100th term is, I could find that. If I wanted to know the 30th term, I could find that. I want to find A sub 15. So I want to know what that 15th term is. So then I'm going to plug 15 in. Okay. And then I'll just evaluate that. So 12, -12, plus 15 minus 1, which is 14, times 3 is going to be 30. So that means that if I were to list out these next several terms, when I get to the 15th term, that numerical value would be 30. Okay. All right, so then for this one, my first term is 55. And now my values are decreasing, which means that my common difference is going to be negative. And it looks like I'm decreasing by 8. So D is going to be -8. So that would make the formula for the nth term 55 plus n minus 1 times -8. So if I want to know, if I were to keep listing out these terms, I want to know the 15th term, be 55 plus 15 minus 1 is 14 times -8. Oops. I would get -57. So just to repeat, what that means is that if I were to keep listing out these terms, when I get to the 15th one, that term would be -57. Okay. All right, so now let's look at these and what's different and what we need to find. So now here we know the 11th term. So I know that A sub 11 is 52. So the 11th term is 52, and the 19th term is 92. And I want to know the 1000th term. All right, so the first thing we have to do, because I don't really want to list out 1,000 terms, I want to know what the general equation is so that I can figure out what the 1000th term is. I can just easily plug in 1000 there to find that out. Okay. All right. Well, think back to what I kind of defined an arithmetic sequence to be. It's just a linear function. So the common difference is really the same thing as your slope. So I want to figure out from my 11th term to my 92nd term, how far did I go? So if I ended at 92 and started at 52, I want to find the difference between those. And then if this is the 11th term and the 19th term, it took 8 terms to get there. So again, because we know that the common difference, every term is different by a constant amount, if you can find the total increase and divide it by how many terms are in between, that'll give you your common difference. So 92 minus 52 is 40. 40 divided by 8 is 5. All right, so I know that my common difference is 5, but in my equation, I need to know what the first term is, not the 11th term. So what I'm going to do now is kind of work backwards from this general form. So in this equation, my variable was like a sub n and then n, because those two always will go together. Well, I don't know what this is now, so I am going to make that my variable. So I'm just going to pick one of these terms. Okay. And so remember, this is what the actual term is. So the 11th term is 52. I don't know what the first term is. That term is the 11th one, so that's n. And then d is 5. And so I'm going to solve for a sub 1. So if I simplify this side, that would be 10. 10 times 5 is 50. And so then when I subtract, I would get a sub 1 to be 2. Now, one thing that you may be able to do sometimes, which we'll kind of look at here, is work backwards to find that first term instead. But working back from 11 is a little bit more time consuming than like working back from 3, which is what we have here. All right, so my general equation would be a sub n equals 2 plus n minus 1 times d. And so now if I want to find the 1000th term, 1000 minus 1 is 999. And so when I evaluate that, I would get that the 1000th term is 4,997. So if you took the time to list out 1,000 terms, that would be the term that would fall in that place. Okay. All right, so this one is kind of similar. I'm given 2 terms, and I want to find the 10th one. So here we definitely were more algebra based. I'm going to do this one a little bit differently because of the closeness of some of these terms, just to kind of give you another option when it's more like easier to do the problem this way. All right, we still have to start out by finding my common difference. All right, so if I want to think about how far I went, what was the difference between 16 and -5? How many spaces did I go? Well, if I find the difference, 16 minus -5 is going to be 21. So my term increased by 21. And from 3 to 6, it took 3 terms to get there. So my common difference is 7. All right, so that means that I'm adding 7 to get from the 3rd term to the 4th, adding 7 to get to the 5th, adding 7 again to get to the 16th. So if I know that my common difference is 7, I can work backwards if I wanted to find the first term. So if -5, this would be the second term, and that would give me my first term. So if I'm going backwards, instead of adding 7, I'd subtract 7. So this term would be -12, and a sub 1 would be -19. Okay, so you can find that more like kind of just using the pattern as opposed to the equation. So that means that my rule would be a sub n equals negative 19 plus n minus 1 times 7. So now we could either find the 10th term by using this formula, or again, if you just wanted to add 7 until you got to that 10th term, that would work too. So negative 19 plus 9 times 7 is going to give us 44. So that 10th term is 44. All right, so we're going to end now by, oh, just kidding. One more before we get to a couple applications. So this one says 97 is the what term of this sequence? All right, so let's kind of figure out what we know. We know that the first term is negative 3, and it looks like my common difference is 4. So if I were to write the general equation for this, it would be a sub n equals negative 3 plus n minus 1 times d. All right, so now I have to figure out, where does the 97 go? Does it go in for a sub n, or does it go in for n? And this is where understanding the notation becomes extremely important. So remember that n is the placement of that term. So is it the 10th term? Is it the 11th term? Is it the 50th term? A sub n is the term itself. It's the number that's in that place. So if I'm looking for the term placement, I'm looking for n. I know the actual term. So I'm going to plug 97 in for a sub n, and I want to know where that falls. So I'm actually going to start by distributing that through. There's a couple other ways that you could solve this. I'm just going to do it this way. So 4n minus 4. So when I combine like terms, I would get that. 97 plus 7 is 104. Divided by 4 is 26. So that means that 97 is the 26th term of this sequence. So if I were to continue adding 4, when I got to the 26th term, that term would be 97. All right, so now we're going to end by looking at a couple of word problems here. So just picking out the same information that we've been looking for just from an application. So it says Rebecca makes $12 for her first hour of work, 17 for her second, 22 for her third, and so on. How much will she earn for her 50th hour of work? And then obviously, wouldn't it be nice if your job was like this? I wish. All right, so I see here key word first, and then 50th hour would mean a sub 50. So this is going to be like these equations right here. We're going to write our formula and use it to find the 50th term. So I first need that equation, and luckily I've got everything I need. The formula for the nth term, my first term is 12, and then my common difference is 5. She makes $5 for every additional hour she works. That's my pattern. So if I want to find the 50th term, be 49 times 5. So she would make $257 in her 50th hour of work. So now let's look at this one, kind of break things apart. So a marching band is arranged in rows. The first row has 3 band members. The next row after that has 2 more than the row before it. So this would be my pattern right here. Okay, so first part is write an equation representing this sequence and then find the number of band members that would be in the 10th row. Okay, so if I didn't include this first part, if I just said how many band members would be on the 10th row, you wouldn't necessarily need an equation. If you just keep adding 2, just go up until the 10th term. It wouldn't take you very long. Just to practice writing the equation, so a sub n, in the first row, I've got 3, and then my common difference is 2. So if I'm looking for how many band members are in the 10th term, I take 3 plus 18, which would be 21. All right, so tomorrow what we're going to do is look at arithmetic series. So in the sequence, that's just a list of terms. We're looking for a specific term number in our sequence. So tomorrow we will look at adding these terms together and finding sums and totals and things like that.